So in this video, I'm going to start another. So I read the question first. For example, here question 13. The diagram shows metal rod suspended in a magnetic field by two vertical conducting springs. Okay, here is a metal rod, that is the black one, that is the horizontal position. This metal rod is suspended by two springs that has spring constant Ka. The cell and the rod have negligible resistance. So this cell, this that is the positive negative, this is the cell is actually it supplies the electricity, or it supplies the current. Okay. And when the switch is closed mean we close this switch mean uh, when we close this switch mean that we connect this terminal mean we close mean the switch is on. Okay. We close mean when we connect these switches, so mean there is a flow of current. And effect of magnetic field is to displace the rod vertically a distance y. So this rod will displace the magnetic field. This magnetic field will displace the rod vertically upward, and it covers a distance that is y, that is equal to y. Okay. Now when both spring constant and the electric resistance of each spring is doubled, so when we double this spring constant and the electrical resistance r, so closing the switch now cause the rod in a display the distance. So we have to find the final distance. New change in distance now the cause the rod to display the distance of. So we have to find the new distance by increasing the spring constant to double, and the resistance is also doubled. So in order to solve this, first of all, we explain this. For example, when we close the switch, when we on the switch, so the current flows through this coil. So direction of current is from positive terminal towards the negative terminal. So the direction of current is from positive terminal towards the negative terminal. Okay. So when the current is flowing and there is a magnetic field that is applies perpendicular, because this cross sign shows the magnetic field into the page. So there is a magnetic force when basically when charges move in a rod, and we applied the magnetic field that is perpendicular to that. So we know that there is a force that acts on this rod, that the rod moves vertically upward. So why it vertically move upward? Because when we apply right hand rule, so if we apply the right hand rule, we must know that the our direction of the magnetic force will be equal to upward. But it is the not the about the right hand rule, because he tells us that the rod moves vertically upward. Okay, there is no confusion in that. Okay. So the rod covers distance of y. So what is happening in this? In this there are two forces acting. So first we discuss the magnetic force. First force is the magnetic force, that equal to ILB. And second one is the spring force, that is the spring acting on the spring, that is from the Hooke's law, that is equal to K into extension E. So extension E, instead of extension E we have extension Y. Okay, where Y is equal to extension. This is from the Hooke's law, and this is from the magnetic force. Okay. So magnetic force pulls this rod towards the y direction, towards the upward. Okay. And it covers a distance of y. Okay. So as we know that these two forces must be balanced, because this magnetic force pulls this rod. Okay. These and the spring, there is a compression in the spring. Okay. So it means the spring force, that is F is equal to Ky, and the magnetic force both are equal in magnitude, because when the rod is moved upward, so similar extension will be produced in this spring. So it means these two forces, we can compare these two forces to find the final distance. So we comparing these two forces, F spring equal to F magnetic. So F spring, we know that F spring is equal to Ky, that is equal to F magnetic. Okay. So we don't put magnetic value because I explained this. Okay. So after changing to resistance to 2R, when we increase the when we double the resistance. Okay. So resistance is actually the opposition in the flow of current. As we know that resistance is inversely proportional to current. Mean if we double the resistance, current become half. Or in other word, we can say that resistance inversely proportional to current. So if we double the resistance, so current becomes half. And when current become half, current becomes half. So new current will be equal to half of the original value. It means current, when current becomes half, so magnetic force also becomes half, because this magnetic force depends on the current, length and magnetic field. So magnetic force also becomes half. So our new magnetic field, magnetic force must be equal to half of the original value, mean half value. So this is equation number 4. Okay, so we come to know that the new magnetic field will be the half. Okay, now we discuss the spring constant. When we double the spring constant Ka, so if we double the spring constant, so definitely when we double the spring constant, so it means, so we double this spring constant, mean we have to apply more force for the same extension. Okay, now we discuss equation number this equation number 3 for uh, new case. For new case, we know that after changing the resistance to double and the spring constant to half, so our new formula will be equal to f spring, dash is equal to f magnetic dash. Dash is the value that is after the changing. Okay, so f spring is k y dash, k dash y dash, which is equal to f magnetic dash. Okay, so this dash is after changing spring constant as well as the electrical resistance. Okay, so k dash is, as we know that k dash is 2 times of the original value. K dash is original value, the so it means k dash is equal to 2k, and y dash we need to find. F magnetic is the half of that value, so y dash is equal to f magnetic over 2 into 2 into k, so f magnetic over 4k. Okay, now we know that y dash is equal to 1 over 4, and this f over k, as we know that f over k, we can see that f over k, fm over k is the original y, because we can see that ky is equal to fm, ky is equal to fm, so y is equal to fm over k. So original extension is fm over k, that is y, so it means y dash must be equal to y over 4. So this equation, option number 2 is the correct option. Correct. So this is mathematical. So if you are confused with this mathematics, so we can also explain in the more convenient way by physical meaning. Okay, actually when we increase the resistance, our magnetic force becomes half by doubling this resistance. So magnetic force become half, and as well when spring constant is double, so it means this spring extend to half. Mean if these two factors become half, so it means our final extension must become 4 times. It must decrease the 4 times, because by increasing just by doubling this resistance, current will become half and magnetic force will become half. So it means this force but that is pulling this, that becomes half. Okay, and when we increase spring constant, when we double spring constant, so it means this, for the same force, the extension will become half, because spring now it for the spring constant is doubled, so it means we have to apply more force. It means force become half, so it means our final value of the extension must be must decrease 4 times. Okay, thank you.